Hello, today I will demonstrate my project where I am using Amazon Web Services to build RAG-based AI chatbot powered by Bedrock. This system can understand user queries, read uploaded documents, provide intelligent context-aware responses, and maintain conversation memory. This application acts as the front-end layer connecting users to my AWS-powered backend. Here you can see the main screen of my application. At the top there is an menu icon to access the chat history of this chatbot, and the title is RAG AI. Here you can upload your domain knowledge to S3 buckets, as our system is reality augmented AI. So here you can edit the options. These are the ready to prompt options to avoid typing, and here we can type our message to our LLM, and it will give the response here from AWS backend. And here you can give the response whether it is good or not. And here we can add temporary files from our mobiles to explain a concept or anything related to the document. And here there is an option to adjust the light mode and dark mode for this chat. This is UI design to enhance the user experience. All user interactions from this app are sent to my backend through APIs. The request goes to AWS Lambda, where it is processed using Amazon Bedrock and the RAG pipeline. The response is generated and sent back and finally displayed in the interface in real time. The chat history you see here is stored and retrieved from DynamoDB, which enables conversation memory. This main goal of this interface is to provide simple efficient way for users to interact with powerful RAG-based AI systems. And this completes the front-end overview of my RAG AI, and let's go to backend. First, I'll show you Amazon Bedrock. Here I am using Amazon Bedrock, which provides access to powerful foundation models. In my project I am using Amazon Nova Lite, which is one of the LLM model from Amazon Web Services. Here in this model catalog we can see so many LLMs. In that I am using Nova Lite. These models are invoked directly from my Lambda function. Now coming to backend, I have built my backend using AWS Lambda, which is serverless service. Here is the Lambda. Lambda handles chat requests, file uploads. It handles the chat requests, file uploads, AI model calls, data processing, everything. It was done from this serverless function running in the Amazon AWS Lambda. Here is my Lambda function code written in Python. You can see here we have used Bedrock LLM and S3 DynamoDB, and we have used Amazon Nova Lite LLM for this. Okay, here is the chatbot document storage S3 bucket. Now let me explain the workflow. When a user sends a message, the request goes to Lambda. It retrieves previous chat memory from DynamoDB. It checks if the user has uploaded any files. If files exist, it performs a search from relevant content. Then it sends the query and context to Bedrock. Bedrock generates the final response and returns it. Now I'll show you DynamoDB. It stores the chat history. DynamoDB is actually used for chat histories in many chatbots, and it it contains the system configurations, everything it will store. It also contains the vector embeddings of documents, so it can search the relevant things user asked about. Here is the vector store and chat memory. It's chat configuration for chat history. Alright. This helps the chatbot remember previous interactions and provide better responses. Now I'll show you S3, Amazon S3 for storage of real data which was given by the user. Here we can store the documents uploaded by the user to retrieve the information relevant to the query asked by the user. And one of the key features of my system is RAG, which stands for Retrieval Augmented Generation. Instead of replying only on the AI model, the system retrieves relevant content from user uploaded files, then sends the context to the model. This improves accuracy and ensures the answers are based on user data. For searching, I use embeddings and cosine similarities. The system compares the user query with stored embeddings and retrieves the most relevant chunks of data. Additionally, I implemented chat memory. The system stores previous messages, summarizes long conversations, maintains context across interactions. This makes the chatbot more intelligent and personalized. Key features of my system include real-time AI responses, file-based question answering, conversation memory, serverless architecture, scalability, and cost efficiency. This is about my total RAG AI from using Amazon Web Services.